So let us have the introduction to three-dimensional geometry. And as I was saying from the beginning itself, there is no difference between vectors and 3D, except that in vectors, we make use of the unit vectors I bar, j bar, k bar to represent any point or any vector. But in case of three-dimensional geometry, we take only the ordered triplet. The same vector a I bar plus b j bar plus e k bar is shown as a comma b comma c as an ordered triplet in three-dimensional geometry. And we will not be discussing about any direction in case of three-dimensional geometry. So if you learn to see three-dimensional geometry from the window of vectors, it will be very easy for you to transform all the concepts of vectors to 3D and thereby from 3D to two-dimensional geometry. So, and whatever you have learned in two-dimensional geometry, all the concepts of two-dimensional geometry can be straight away transformed to three-dimensional geometry by simply the addition of z coordinate. Simply the addition of z coordinate gives you the transformation of two-dimensional geometry concepts to three-dimensional geometry. So let us have a glance at all those concepts and we will work out some problems based on it. Let me share my screen. This is now in the three-dimensional geometry. Let us see the introduction. Now, this is the introductory part of three-dimensional geometry is nothing but, the distance. It starts from the distance formula. In the distance formula in two-dimensional geometry, it is x2 minus x1 whole square plus y2 minus y1 whole square. And here it is plus z2 minus z1 whole square under root. So that makes no difference between that and this except the z coordinate. So that is to be understood in case of three-dimensional geometry. So in the space, the three-dimensional plane, the three-dimensional geometry, you will have obviously x-axis, y-axis, and z-axis shown there. And whatever the point is to be represented, that point in the space contains x-coordinate, y-coordinate, and z-coordinate. So here, always remember these three lines intersect the space into 8 equal parts. 8 equal parts. 8 means octa. 8 is equal to octa. That is the reason why each part is said to be an octant. We can say each compartment, let me say, is said to be an octant. The reason is the space is divided into 8 equal parts by these three mutually perpendicular lines. And understand that in vectors, mutually perpendicular lines is a special case. What I mean to say, I bar, j bar, k bar we take in vector algebra. It is a special case. But in vectors, what we say, to represent any point in the space, we need not have to have always three mutually perpendicular vectors to represent a point in the space. But what happens in case of three-dimensional geometry, it is mandatory that you must have the mutually perpendicular lines. I'll explain you like this. For example, if you take a vector like this, it is a bar. This is another vector, b bar. And this is another vector, c bar. If these three need not be mutually perpendicular to each other, but if it is a bar, b bar, c bar, and if you take any point here, if these three are non-coplanar, that is sufficient for us to express any point in the space using vector algebra. So that can be denoted as x a bar plus y b bar plus z c bar. So where I bar, j bar, k, a bar, b bar, c bar are three non-coplanar vectors. But as a special case, we make them mutually perpendicular to each other to simplify the geometry. So we call them as I bar, j bar, k bar, where I bar, j bar, k bar are the unit vectors along the three mutually perpendicular lines. They are said to be orthogonal, triad, orthogonal triad, what I mean to say. So this orthogonal triad, so this case you don't find in three-dimensional geometry, which case A bar expressing any point in the space with the use of three non-coplanar vectors A bar, B bar, C bar. You don't find it, but you don't find it in three-dimensional geometry, but you will get it. A special case that is mutually perpendicular in this case. That's what I have shown even in the image also. You can see, I'll show you that. Just if you see, do you see three mutually perpendicular lines here? This is one is above blue, red, and sky blue lines are there. These three are mutually perpendicular lines, which we can take it as one as x-axis, y-axis, and z-axis. And these three only dividing the space into 8 equal parts. This is the octant in the. If you see the right-hand side diagram, that is first octant, you can say. Similarly, adjacent to this, one, adjacent to that, one more, adjacent to that, one more, and below 4, above 4, below 4. Totally 8 will be there. So that divides into 8 equal parts. That's the reason why we term each one as an octet. Okay. Now, this is unlike you have in two-dimensional geometry, first quadrant plus second quadrant minus third quadrant minus fourth quadrant plus minus like that. Here also in the octets, you will have the signs. You will have the signs. For the first octet, you will have all plus. But in the remaining octets, obviously, according to the sign of the coordinates, you can decide the octet. But what is that you have to mostly have is that you must have good imagination in solving the problems. In whether it is vector algebra or three-dimensional geometry, you must have very good imagination. If you have good imagination, obviously you must have the good imagination, because we all would be engineers. You must have that. Without that imagination, nothing can be constructed, nothing can be done. So here, the three-dimensional geometry, you have to make use of it like that while solving the problems. Imagine the room in which you are sitting, and you can derive the conclusions from the room in which you are sitting, because it is a three-dimensional one, and particularly every construction is if you take the angle between the floor and the wall, it is always 90 degrees. You don't find other than 90 degrees. You might have observed in any construction, whatever the construction you take, it is the angle between floor and the wall is always 90 degrees, and hence it comes under three-dimensional geometry only. So that is the reason why you can see in the different octants, he has given the different signs here. First octant, second octant, like that. We don't need to have this, and there is no much preference for this one. It is understood. It is understood. Similarly, what are the other methods of defining the point in the space is the parametric form, but we don't need it now. That is polar form. We don't need it now, and because in three-dimensional geometry it is sufficient for us. And I don't want to make more. I don't want to insist on this formula, because it is understandable that the distance between 2 points is always x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, so that is a distance formula. And one more important thing, what is that you have to understand is that PA is equal to root over y square plus z square. PB is equal to root over z square plus x square, and PC is equal to root over x square plus y. So how PA is root over y square plus z square, and how PB root over z square plus x square, and how PC root over x square plus y square? This is to be understood, please. This is to be understood. That is distance of a point from the coordinate axis. Distance of a point from the coordinate axis. Let me show you that. Let me show you that. One moment. See, here, Vinith and Kaushik.
Sir.
Yeah, Vinith.
Sir.
Yeah, now what is that I'm going to discuss here? If you have a point in the space, for example, this is x-axis and y-axis, and this is z-axis. Now,
Okay.
if you take any point here in the space, for example, I'm taking a point P, X, Y, Z. And I want the distance of this point from x-axis, for example, distance of this point from x-axis. Then very simple is that you have to draw a line which is perpendicular to x-axis, because distance is always perpendicular. And this is angle is 0, that is angle is 90 degrees. And if you take this point as an A, obviously, you know, on x-axis, you will have only x coordinate, rest of y, z are 0. Then you tell me the distance between these two, root over x minus x whole square plus root over y minus 0 whole square plus root over z minus 0 whole square, which becomes root over y square plus z square. I hope you understand what I'm saying, Kaushik.
Yes, sir.
Similarly, if you want the perpendicular distance from y-axis, no, generally, this is because it is a three-dimensional one, you may not be getting the exact figure here, but in the similar manner, you can understand that PB, if you take the perpendicular distance from this to this, let me say, y-axis. And what happens, PB, obviously, it is in the cyclic order. In the cyclic order, PB distance is nothing but root over z square plus x square. Similarly, PC perpendicular distance, that is, PC means perpendicular distance from this point to z-axis, will be obviously taking in the cyclic order. This is what you have to understand. So, distance of any point from x-axis, root over sum of the squares of yz coordinates, from y-axis, root over sum of the squares of xz coordinates, from z-axis, sum of the squares of obviously x and y coordinates. I hope you understand that, Kaushik.
Yes, sir.
Pranit,
Sir.
I hope you understand what I'm explaining.
Understood, sir. Yes,
This is what I derived now. This is PA.
yes, sir. The distance form. Yeah.
PA, PB, and PC. This is what I derived now. Now,
Okay,
if you want the question, just to see the question there now, below it, direct question here, the distance of the point 435 from the y-axis. From the y-axis means obviously,
EB, sir.
that is root over 4 square.
25 plus 16.
That's it.
41, sir.
That's it. Root 41. Okay. Similarly, you can not only this, you can define the distance of the point P from the plane also. I'll tell you like this. This is the point P, X, Y, Z. This is XY plane.
Yes, sir.
If you want the distance of the point from x-axis, this is the distance. From y-axis, the distance. From z-axis, this is the distance. But from xy plane, if you want, no, if you drop a perpendicular from P onto xy plane, on xy plane, which coordinate is 0? Z is 0, remember that. Xy will be there.
And Z will be 0.
That is 0.
Okay.
So what is that? You have to understand x comma y comma 0 is the foot of the perpendicular from P onto on xy plane. So what is that happening? Pn, you can find out. Pn is nothing but x2 minus x1 whole square plus y2 minus y whole square plus z2 minus z1 whole square, which is nothing but z.
Yes.
Which is nothing but z. So very simple is that the perpendicular distance of a point xyz from xy plane is z, from YZ plane is X, from ZX plane is Y. That is understandable, and I need not have to extend it. It is very simple. Very simple is that if you take did I explain it properly? Please, do you understand what I'm explaining, Pranit and Kaushik? Please respond.
Understood, sir. Understood.
This one, if I take a plane now, and if I take a point here, P, X, Y, Z, what is that we discussed previously is that it's a distance from x-axis we have taken. Now, what is our interest here? We want to find out its distance from XY plane. We want to find out its distance from XY plane, please. Okay, so here it is. Here it is. XY plane means you have to drop a perpendicular from P onto XY plane. This is the perpendicular. Somewhere it meets on XY plane. When it meets on at some point on XY plane, what happens? On XY plane, equation of XY plane, I need not to tell you that. Further, we will have the equation of the plane and all. But equation of XY plane is Z is equal to 0. And hence the same points will be there, same coordinates will be there, except that you will get Z0 here, Z0 here. Now find out the distance between them. It is nothing but Z. Similarly, from YZ plane, anyone please respond? From YZ plane, what should be its distance?
Sir, X, G.
YZ, no?
YZ is G. X will be 0, sir.
That's right. You're right. X will be 0. That's okay. And YZ plane means the distance will be X only.
Yes, sir.
From ZX plane, it will be from ZX plane. This one
Y
is,
will be 0.
this is Z. This is Z. From ZX plane, it will be Y. ZX plane, it will be Y. So this is to be understood. It's common sense. That's what I'm saying. You must have a good imagination in solving the problems of vectors and 3D, which is very, very important, please. Which is very, very important. Now, let us continue with the theory given there. So the distance of the point from y-axis, we have already seen. It is root over x square plus y square. That is done. Next one, if you see this question, yeah. Let me write, yeah. And you can also do that in parallel with me, please. Come on, try it. Kaushik,
Sir,
finish your lunch.
no, sir. No,
Lunch, not lunch, dinner. You finish your lunch long back. Is it vegetarian lunch or non-vegetarian lunch today?
it's combined, sir.
Combined.
Soup lunch.
Soup, you bring, get a soup so that you'll get more energy. 8 minus 7, 5. Now, are the vertices off, he's saying. Just, I'll tell you how to solve this within no time. What I mean to say by within no time, I have not seen the options. Let me see the options. Just a moment, please. Let me see the options. Let me check the options. The options are rectangle, square, parallelogram, and none of this is given. So, for all this, I'm just reminding you, for all this, you must be knowing that. That is, if you take a parallelogram, for a parallelogram, the opposite sides are parallel to each other. And for a rectangle, opposite sides are mutually, of course, opposite sides are parallel and the adjacent sides are mutually perpendicular to each other, even if it is the same case with square also. But all the sides are equal in case of a square, and adjacent sides are, of course, perpendicular to each other. And if you see the case of rhombus, for a rhombus, all the sides are equal, of course, but the angle between the adjacent sides is non-90 degrees. Angle between the adjacent sides is not 90 degrees. So what is the commonality of all this? Common property of all this is the lengths of the diagonals. If you compare A, B, C, D, if you compare the lengths of the diagonals A, B, C, D, then the diagonals in case of, just follow this. You may be knowing this, but I'm insisting. This is AC. This is BD. Now, if you see the parallelogram, your AC not equal to BD. And in this case, AC also not equal to BD. In this case, AC is equal to BD. In this case, AC not equal to BD. And this one also equal, no? Equal. For a rectangle, do you tell me whether for a rectangle equal or not?
Yes.
Right. Anyone, please
Sir,
respond.
equal.
Respond, please. In a rectangle,
Equal.
I mean, whether they are equal or not. For
Equal,
two of
sir.
them, it is equal. For rectangle and a square, it is equal. So if you find out first AC and BD, then it is understandable that among the four, you can confirm yourself to, or you can limit yourself only to only two. That is, let us find out the lengths of the diagonals in this case. Now, let me write AC here. AC, please. AC, 4, 4 plus 4, 8, 8 plus 4, 12. So AC square is 12. BD square, please. BD square. 16. 16 plus 16, 32. 32 plus 16. 48. Or there, everyone, please. Everyone, please respond. What is that? I did a mind calculation here, and we have got the diagonals unequal. Then when they are unequal, which case it comes under now? Please respond. Either it should be a
Parallelogram.
parallelogram or a rhombus.
Rhombus.
Or a rhombus. But what is the difference between the parallelogram and rhombus? In a rhombus, the sides are equal and even the diagonals mutually perpendicular to each other. This is also a property to be remembered. These two are mutually perpendicular to each other. But here they are not mutually perpendicular to each other. Now, what is that to be done now? Now find out the lengths of adjacent side. Then you can decide the answer. Now find out AB square, please. I'm writing that 1 plus 1, 2, 2 plus 1, 3. Written. BC square, please. BC square. This is 9 plus 9, 18. 18 plus 9, 27. Here, AB not equal to BC. And hence you have to understand that it forms a parallelogram. I hope you understand what I'm doing. So whenever you are deciding the type of the quadrilateral, first of all, find out the length of the diagonals. If the lengths of the diagonals are equal, it should be either rectangle or square. But if the length of the diagonals are unequal, then it should be either a parallelogram or a rhombus. So we have got the lengths of the diagonals unequal. And hence we understood that this forms either a parallelogram or a rhombus. But for a rhombus, the adjacent sides are equal. But for a parallelogram, adjacent sides are unequal. So we found the lengths of the adjacent sides, AB square, BC square, they are unequal, and hence it forms a parallelogram. I hope you understand that. It's a simple one.
Yes, sir. Understood.
Manas, do you hear me?
Yes, sir.
Vaibhav? Vaibhav, do you hear me? And Pranay?
Yes, sir.
So now the section formula I need not have to insist upon. The section formula is Just extension to two-dimensional geometry only. Just extension to two-dimensional geometry only. Mx2 plus nx1 by m plus n, my2 plus n by 1 by m plus n. Mz2 plus nz1 by m plus n. But in the vector form, this is giving the section formula like this is wrong. You should, and even in the lower class also, they teach it like this, but not necessary, and it should not be done also. So dividing externally means ratio will be automatically negative. That's all. It is not a separate formula. This is only the formula. That you should not learn them as two formulae. But in case of, I'll tell you, the transformation of vector algebra to three-dimensional geometry, so that every formula of vectors can be transformed to 3D, and every formula of 3D can be transformed to vectors. How? This is very simple, like this. If you have, are there every one of you, please? This is point A, whose position vector is A bar. This is point B, whose position vector is B bar. And there is a point P, which divides it in the ratio something m is to n. Then your P will be mb bar plus na bar upon m plus n. Listen, please, listen. This is what you have to understand with regards to the vectors. This is what you have to understand with regards to the vectors. But how is it to be converted to three-dimensional geometry? Very, very simple is that. Conversion to three-dimensional geometry happens. This A bar is to be taken as x1, y1, z1. And this B bar is to be taken as x2, y2, z2. So what does it mean? This triplet is packed as a vector. This triplet is packed as one in vector algebra. Only thing is you have to understand it as three components. Three components. When you convert it to three components, no, in every case it happens, please. That is why I'm explaining you this. B bar is that x2, y2, z2. And A bar is x1, y1, z, whole divided by m plus n. So when you separate x coordinate, you know what happens? So this is mx2 plus nx1, this one nx1 by m plus n, the x coordinate you have got. And so on, y coordinate and z coordinate. That's it. So this is the conversion you have to understand from vectors to 3D. If you understand like that, that will be more comfortable. And even I ask the students always to remember in the vectorial form only better. The reason, I'll tell you, just a moment. If it is vectorial form, what happens? mb bar plus na bar by m plus n. Let us suppose we have not taken vector form. Let us suppose we have not taken vector form. I removed it. Even I am removing this also. Even I am removing this also. And this also I am removing. Now, what I ask the students always, even in the Cartesian coordinate geometry also, that is the analytical geometry or coordinate geometry also, what is that I ask the students always? To remember the section formula like this. Like what? mb plus na upon m plus n. That's it. Understand that? mb plus na upon m plus n. So, if you remember like this, what happens now? It will be easy for you to simplify also. For example, you are given a point P here. You are given a point P here. 1, 2, 3. Let me say. You are given another point here. -1, 3, -2. You need B here, for example. You need B here. Then you are given a ratio also, like something like 2:3 given. Then you have to find out B there. Then we write P is equal to mb plus na by m plus n. But what is that we need? We need B here. So let me write B now. Cross multiply this. Now let us apply this first. P is equal to, come on, tell me, anyone please. This is M is 2, B is B only, N is 3, A is A only, right? Like that only. I'll come to you now. How simple it will be. By 5. By 5. What happens? You need B, no? This will be simply 5B minus 3A divided by 2. Kaushik, are you there? Vineet? 5 times of P, this is 5, minus 3, minus of minus 3. I'm writing that directly, understand it please. 5P means 5 into 1, 5, minus of minus 3, 5 plus 3, 8, 8 upon 2, 4. Directly. This is 5P, 10, 10 minus 9, 1, 1 upon 2. It is again 5P here, that is 5 3 is 15, 15 plus 6, 21 by 2, that's it. You can find out like this. So instead of understanding them in the split form, if it is a board examination, you are more comfortable, you have a lot of time to solve the problems. But if it is objective examination, better you work out the problems like this. Take the ratio formula, section formula like this, and thereby it will be easy for you to solve the problems. I called Kaushik and Trinit, you're not responded.
Sir.
Sir, I'm there.
I hope you understand this.
Yes, sir, understood.
So that is a section formula, and if it is external division from your lower classes itself, you are learning that the ratio becomes negative. I need not to insist on it. So don't, but what I suggest you, don't take it as a separate formula, even if it is taught as a separate formula in your lower classes. Because here itself, this plus need not always be plus only. That becomes minus if the ratio is external. That is, if your ratio is negative. What I mean to say, if the point is dividing it externally, automatically that becomes negative. Okay, so let us move. And the midpoint formula, which is for the revision sake, that's it, A plus B by 2. And I ask the students to remember this as A plus B by 2, that's it. P is equal to, or midpoint, no, symbolically we will use it. M is equal to A plus B by 2. If you want B, no, that is twice M minus A. I'll take an example so that you'll be more comfortable. What I mean to say here, for example, you have a line. You have a line. Whatever the concepts or whatever the short forms I'm teaching you here is very much applicable even to two-dimensional geometry. You are given a midpoint as something like minus 2, 3, 4. You are given a point A, one extremity as a minus 3, 4, 4, 5, and you have to find out this point B. What I'm suggesting you, just remember the form, just remember this notation. That will be easy for you to write B. M is nothing but A plus B by 2, and B is nothing but twice M minus A. And the midpoint is given. Twice M minus 4 plus 3, 1. Twice M, 6 minus 4, 2. Twice M, 8 minus 5, 3. That's it. Within one step, you can write it. So, follow this. Follow this, please. What I suggest you. Follow this. This will be much useful, not only in three-dimensional geometry, but also throughout the coordinate geometry, even in 2D also. Whenever the midpoint is given, one extremity is given, other extremities we find out, then you can make use of this. Twice of the middle point minus given point. Twice of the middle point minus given point gives you the other extremity. Okay, so next, coordinates of the general point is given anyway. Whenever we work out the problems, I'll be doing that. Now, the triangle centroid. Centroid of the triangle, I need not have to insist on it because you have learned it in your 10th class itself. But it is three-dimensional geometry. But this is new to you. This is new to you. Like what? Like what? This is a tetrahedron. This is a tetrahedron. Okay. So let me elaborate this in the working rule. How do we proceed to work out in the objectives? That's what I'll show you. Now, let me take a triangle. Kaushik,
Sir,
you tell me a point here, A of your choice, any point here of your choice in 3D.
1, 2, 3.
Very good. They are in AP with common difference 1. And Praneeth, tell me a
Sir,
point.
4, 5, 6.
You want to take GP?
Ah, yes, sir.
Come on, tell me.
4, 5, 6.
4, 5. That will become an equilateral triangle. Anyway, Vaibhav, tell me a point of your choice. Armanas, whoever. Come on, make it fast.
7, 8, 9.
12, 15.
Okay, that's good. But I'm not going to take C here. I want this. I'm given centroid. I'm given centroid. The definition of centroid won't change. Centroid definition is a point of concurrence of medians. Point of concurrence of medians is the centroid. The same even in three-dimensional geometry also. Definitions won't change. So I'm given A, B, but not C and G. I'm given A, B, G, but not C. So G, let me take any point of my choice, -2, -3, 1. Then I need the coordinates of C. Then I don't say that you cannot work out this problem. You can do this comfortably. But what is that I'm telling you is how to work out this in an easier way, easy method. That's what I'm saying. See, follow this carefully. This is simple only. Like I'm not, I suggest you not to split them as components. Straight away write them as A plus B plus C by 3, which you do in the vectors. In the vectors, it is to be taken as A bar plus B bar plus C bar by 3. So we can say that indirectly it is a vector method. Now what is that I want, I want C. Now this becomes 3G minus A minus B. What is 3G? Triple of 3 times of G, -6, -1, -7, -7, -4, -11. Now 3 times of G, -9, -2, -11, -11, -5, -16. And 3 times of G, 3, -3, 0, -6, -6. See how many steps we have taken. Just in the second step, we can write the answer. That first step is I'm asking you to remember. I'm asking you to remember. So this is a method you have to follow in the objectives to work out the problems. Similarly, the special case of three-dimensional geometry, is a tetrahedron. Tetra stands for 4. Tetra stands for 4, and hence 4 stands for 4 planes there, 4 planes. So let me show you that. Let me show you that how the tetrahedron will be. This is the base, let me say. And I will take a point which is not lying on the plane of, let me name this also, on the plane of ABC. Let me take a point which is not lying on the plane of ABC. This is point P. So now join this AP, PB, and PC. This forms a tetrahedron. Now, if this forms a tetrahedron, what makes the difference between the formula of centroid formula of triangle and the tetrahedron? No difference at all. No difference at all, except one extra coordinate. What is that extra coordinate there? Because here you have 3 vertices, there you have 4 vertices. And what are the properties here? And what is the formula here? There it is a plus b plus c by 3. Here it is simply a plus b plus c plus d by 4. Let me change this for a better understanding. As d. Okay, a plus b plus c plus d by 4. So if you are given 3 vertices and the centroid, then you can find out the 4th vertex. D is equal to 4 times of G minus A minus B minus C. See, are you there, every one of you? Please respond. Respond, please. If you respond, I'll have more energy. Otherwise, whether you are listening or not, I don't understand. Please. Every one of you, please.
I'm there, sir. I'm there.
Kaushik, Vaibhav, Manas,
Yes, sir.
Anshuman,
Yes, sir.
Pranay. Yeah. So this is the 4th vertex. And what is the similarity between the properties of the triangle and the tetrahedron? You know, I need not have to tell you, in your lower class itself, you have learned it that the centroid always divides the median. Centroid always divides the median in the ratio 2:1. But the median in case of the tetrahedron, how is it defined? It is simply like this. Take the centroid of triangle ABC. I repeat, take the centroid of triangle ABC. Let me say this as some G1. Let me name it. Let me say it as G1. Now, join the G1 to the opposite vertex. This is very simple, yeah. This is very simple. Like it is the midpoint of the side. Here it is midpoint of the triangle. Kaushik. It is midpoint of the triangle is nothing but centroid. You know, I need not to tell you that. Now, centroid in case of tetrahedron, divides it in the ratio 3:1, but not 2:1. This is an important point to be remembered, because
Yes,
whatever
sir.
the syllabus is there in the higher level that is removed for this year, that means they can concentrate more on the basic concepts like this. You must take care. What is that? Median is the line joining any vertex in the midpoint of a triangle in case of a triangle. But median in case of a tetrahedron is the line joining any vertex to the centroid of its opposite triangle. In case of a triangle, the centroid divides the median in the ratio 2:1. In case of the tetrahedron, the median is divided by the centroid in the ratio 3:1. So this is what the comparison you must have with regards to the triangle and tetrahedron. And tetrahedron case is possible only in 3-dimensional geometry or vectors. Okay. Now, that's what it is given in the split form. But I don't suggest you to remember like this. If you are remembering like this, that's okay. But in the working, to work out the problems in a faster manner, what the method I taught you is more comfortable. So now that is what he has given here about C and R. An area of the triangle. Just this is also an important point, please. Important point. That's what I discussed in the previous class, Praneth and Kaushik. Area of the triangle, just see the formula in three-dimensional geometry.
Yes, sir.
See, what is that given here? Just if you see now, this is area of the triangle in case of three-dimensional geometry. Delta x is this one, delta y is this one, delta z is this one, and you have to find out this delta, this delta, this delta. Delta means determinant.
Yes, sir.
And you have to
Determinant.
square them and add them and find the square root of it to get the area. That much bigger it is
Okay.
in three-dimensional geometry. But I discussed it thoroughly in the previous class and in the vector product. It is very simple in case of vector algebra. It is half modulus of AB bar cross AC bar. Do you remember this, Kaushik?
Yes, sir.
Better, if I take an example on this, you will be more comfortable, what I feel, because if you apply three-dimensional, you need not to remember this also. That's what I'm saying. You need not have to remember three-dimensional geometry, area of the triangle in three-dimensional form. If you are remembering this vector algebra, that is the reason why I put the heading as vectors and 3D. In our state board, it is given as, I've been telling you, in our state board, it is given as one paper in vectors, in the algebra part, and three-dimensional geometry in the second part. Okay, it's not like that. Vectors and 3D, both are same. Both are same. So let me explain you in a simple manner and how fast we can work out the area of the triangle in three-dimensional geometry, not using three-dimensional formula, but using vector formula. So I'm taking 3 points here, -1, 2, 3, and -4, 3, -1, and C, one more point, this is 5, -3, -1. Let me say. Now I need delta ABC here, which is nothing but area of the triangle, half modulus of, you can write AB bar cross AC bar. AB bar cross AC bar. I taught you even in the anti-clockwise direction it is to be taken. Kaushik, if you remember, you said wrong in the previous class. If you want to take it from B, take it as BC cross BA, because anti-clockwise direction you have to consider. If you want to take it from C, CA cross CB, anti-clockwise direction. If it is modulus, there is no use at all. There is no use at all because modulus makes it what? Modulus makes it what? Even if the direction is reversed also, because we are using modulus, that makes that minus also plus. I hope you understand what I'm explaining. The rest of the people, Vaibhav, Manas, Anshuman, Tanaya.
Yes, sir.
Pranay, do you listen to me?
Yes, sir.
You arrived second time, no?
Sir?
First time you arrived and again you are third.
Yes, sir.
Yeah. Is there any network problem there?
Yes, sir. Power cut.
In chat. Okay. Now, what is that AB bar here? AB bar is OB minus OA. Mind calculation. -4 + 1, -3. Praneth, this is OB minus OA. I'm writing 3 - 2, 1.
Okay, sir.
-1, -3, -4. And AC bar means OC minus OA. 5 + 1, 6. And -3, -2, -5. And -1, -3, -4. Simply you have to find out the determinant of this. Instead of finding those many determinants there in three-dimensional geometry, never even remember that. But use vector method, even if it is three-dimensional geometry. No confusion. Vectors and 3D are one and the same. Half modulus of. This is -4, -20, -24i. And it is -24, -12, -36j. And it is 15 - x, 9k. You have to find out the modulus of this. And is there anything common we can get here? 3 can be taken common, no?
Yes, sir.
If you take 3 common, this becomes 12. 12 square, 144. If you take 3 common here, no, this is 8 square. We have taken 3 common, no? 8 square means 64. And it is 12 square, 144. And 3 square, 9. This is the answer. This is square units. See the comparison. See the comparison to find out the area of the triangle in 3-dimensional geometry. So, make use of vector formula to find out the area of the triangle, please. To find out the area of the triangle. Okay. Pranit, are you hungry? Pranit, Babu.
Sir, I'm not hungry.
Now it is again 9 o'clock. It's
Not a problem.
touching 9
After it, again, I'll feel sleepy, sir. It's better if I listen and go in.
Right now, because it is the introductory part of 3-dimensional geometry, how do we check the collinearity? Anyone in the class, you can respond. If you respond, I'll have more energy. You tell me, how do we check collinearity in 2-dimensional geometry? Anyone in the class? 2D.
Sir,
How do we check collinearity in 2-dimensional geometry? What a people you are. Why Manas? Why are you not responding? AB plus BC is equal to AC. Or otherwise, we find the area to be 0. Correct or not? If 3 points are collinear in 2-dimensional geometry, 3 points are collinear in 2-dimensional geometry, A, B, C are there. Then if you find out AB distance, BC distance, and AC distance, AB plus BC gives you AC, then we say that they are collinear, or otherwise, Pranit, you know that you can find out the slope also. Correct or not? Slope of AB is equal to slope of BC. So there are 3 methods in 2-dimensional geometry. Distances, sum of to any 2 distance is equal to third distance. Area of triangle is 0. Slope of AB is equal to slope of BC. And all this we have in 2-dimensional geometry. But in 3-dimensional geometry, you don't have slope concept. And even I have just now explained you finding the area of the triangle. Of course, area of the triangle can be found out. And distance will always be there. But unlike that, the concept of slope is to be seen in 3-dimensional geometry. I repeat. You have to follow this carefully. Nowhere this type of explanation will be given in the books.
Okay, sir.
I'm not exaggerating myself, but I'm giving you the techniques to remember easily. What is that? First, I asked you about 2D.
Yes, sir, 2D.
There are points x1, y1, x2, y2. Kaushik, x3, y3. Or collinear. Then how do you say? AB, find out the distance. BC, find out the distance. Something like AC. This first method. Second method, do you tell me, Kaushik? Area of triangle ABC.
yes, sir.
Can you tell me third one similarly? Slope. Slope of AB. In some other previous class, the Pranit told me this, but now he is not responding. Slope of AB is equal to slope of BC also will give you they are collinear.
Collinear. Yes, sir.
But in case of three-dimensional geometry, how do we decide it? Generally, the students get confused, and up to this, it is okay because you have learned a little or more also in your lower classes itself about this, in your 10th class, 9th class itself. But here, I'm saying A, X1, Y1, Z1, B, X2, Y2, Z2, C, X3, Y3, Z3. Or collinear. How do you check it? Anyone? Anshuman, Manas, Siddharth?
AB is equals to lambda is
Yeah, tell me. That's good. AB is equal to lambda.
AC.
Very good. Kaushik, in vectors, we have already taken a linear relation between them. AB bar is equal to lambda into AC bar or lambda into BC bar, something like that. Okay.
Yeah.
Number two, finding the slopes. Finding the slopes case is there in two-dimensional geometry, but it is not there in three-dimensional geometry. But how do we see this? You have to compare the DRs. DRs of AB and DRs of AC are equal. I'll call you back. 10 minutes. So DRs of AB, if you write no, DRs of AB, if you write X2 minus X1. It is just like slopes. Slopes are replaced by DCs and DRs in 3D. Slope in 2D is replaced by DCs. X2 minus X1 by X3 minus X2. Come on, anyone? Do you extend this? Y2 minus Y1 by?
Oh, Y3 minus Y2.
Z3 minus Z1 by?
Z3 minus Z2.
Sorry, Z2 minus Z1 by? Z2 minus Z1 by? Z3 minus Z1, Z2. Or otherwise, just now I said, half modulus of AB bar, class AC bar is equal to 0. See, all the three I have told you. I explained you all the three, how to convert 2D to 3D. 2D to 3D. And as Manas was saying, this is AB bar is equal to lambda, AC bar is in the form of vectors, but if they are collinear, you will have simply this can be carried. This is universal formula, let me say. Which one? I'm talking about this one. AB plus BC. Distance is always common. What I mean to say, AB, if they are collinear, AB plus BC is equal to AC. Sum of any two distances must be equal to the third distance.
Third distance, yes, sir.
This is what you have to understand. Okay. Now, let me take a problem so that you'll be more comfortable. Let me close the session with this problem. Okay. Now, I'll take a point here, A minus 2, 3, 4. And B, 7 minus 2 minus 1. C, A minus 2, 4. Or collinear. Now I have to change one more there. Let me say this as B. Then A comma B, follow this carefully, please. A comma B. You have a good number of previous questions on this concept. Then A comma B. What is that I said? DRs of AB and AC are proportional. Which implies, come on, tell me now. X2 minus X1, 7 plus 2. I'm writing this for your better understanding. Please understand this. Understand this carefully. This is not just like in vector algebra, OB bar minus OA bar. OB bar minus OA bar. Here we write it as x2 minus x1. Come on, tell me please. X2 minus x1, 7 plus 2, 9,
9.
divided by a minus 7. Correct or not? You can even take a plus 2 also, no problem. But you must follow only fixed coordinates. Like I'll tell you, Manas, whatever you said now, this is nothing but same. What you said is same. What I'm explaining is very much similar to that only. What you said, AB bar is equal to, you said lambda AC bar, no?
Yes, sir.
I'm telling this as OB bar minus OA bar upon OC bar minus OA bar is equal to lambda. This is what you have to understand. Maharaj.
Understood, sir.
So if you want it in three-dimensional geometry, every concept of vector can be converted to 3D. So that's what I'm doing now. Come on, tell me please. Tell me that. 7 plus 2. Kaushik, Chibnan, please tell me that. 7 plus 2. 9 by a minus 7
Yes, sir.
is equal to, come on, tell me, minus 2 minus 3. Minus 5.
-5.
Right? Minus 2 plus 2. Whoa. It got 0. No problem.
Where is it? -9, 5 answer.
No, which one? Minus? Answer.
A is equal to -9, B is equal to 5.
Good. So this is minus 2 minus 3 minus 5 and minus 2 plus 2 0 and minus 1 plus 4. This one minus 1 minus 1 minus 4 minus 5 and it is B plus 1. Generally, whenever the denominator is containing 0, we'll be worried. But here it's no problem because it is a ratio. Now cross multiply this. This is 0 is equal to minus 5 into a minus 7. And here also 0 minus 5 into b plus 1 is equal to 0. What is the answer you said? Minus, this is a is equal to 7 and b is equal to minus 1. Is it? Just check it out.
Yes, sir.
That's it. That means you got the same points here. Because I formed the problem here. Just check it out. What is the answer we got here? 7 minus 2 same and b minus 1 same. So the same answer we have got, but I have to change the point in such a way that there is you will not be getting 0 here. So very simple correction I'll do. Very simple correction. I'll make it as plus 2, no problem. Then what happens? You tell me now. What will be the denominator? Minus 2 minus 2 minus 4.
-4.
Yeah, minus 4. And thereby you will get this one. Let me convert. Yeah. What's it? Now this is minus getting cancelled. And 5a minus 35.
So A is 26 by 5 and B is -5.
What is A, please? Oh. A is here 39 4 36 plus 35, no? 36 plus 35 is how much? 71 by 5. And here this b plus 1 is equal to -4. And b is equal to -5. Correct, Anshuman? Is it correct? 5b plus 5 is equal
Yes, sir.
Oh, that's right, -5. This is what you have to understand. And what I want to make you more clear is that 3D and vectors are no way different. 3D is equal to vectors. Vectors is equal to 3D. makes no difference. That is the reason why I have shown you the vector form here, and in parallel to that, 3D form here. In 3D, we call them as DRs or DCs. In vectors, we call linear combination. Linear combination. Okay. Now let us continue this in the